Hey, today on the Joe and Friends show, we got Ori Reshef, the VP of Products of Varada. So this can be a pretty exciting conversation. Varada is working on some really cool stuff when it comes to making data lakes faster. So Ori, welcome to the show.
Thank you very much, Joe, for having me. It's a pleasure.
Yeah, likewise, for sure.
Very excited to have this conversation with you.
Yeah, likewise. Yeah, pre-show, I think we hit it off really well. So this is gonna be fun. Cool. So for people who don't know who you are, what Varada is, you want to give a quick intro about that?
Sure. So, Ori Reshef, I've been the VP of Product for Varada for the last 3.5 years. Time flies when you're having fun.
Yes.
And there is actually a funny story of how I joined Varada. So in my previous position, so I've been in and around the data business for around the last 2 decades.
Mhm.
Uh, so only reveals my age. And my last position was as head of data products at a company called Clicktel that was bought by the French company Content Square.
Mm.
What Clicktel did is in-page analytics. It's real marketing intelligence. So mouse moves, clicks. You can imagine that the data that is gathered in this context is a log data of every millisecond mouse move, key, stroke, etc. So imagine a huge log that is transmitted every 5 seconds eventually into a data lake, and giving the Fortune 500 marketing intelligence on customer churn, on how to lifetime value of a customer, behavioral insights on the persona. So very deep insights going and very valuable business-wise for the Fortune 500 companies. So it was a very interesting business, and this is where I fell in love a bit with the combining data and behavioral analysis. So we worked with PhDs in psychology and behavioral psychology, and try to model behavior through that. But we didn't start off like that. My mandate was, okay, we have competition. The market is starting to grow, and there are other companies doing this kind of analysis, and they're doing it on more historical data. If you're doing it on 7 days, they did it on 30 days or 90 days. They're giving more insights. And my job was to do the same and try to take the company to the next level. So I said, okay, great, let's look at the data. And I go and look at the data warehouse at the time. We worked with Vertica, very popular. And I'm looking at the data, and I remember it clearly. It was a rough day at the office. So kind of 70 columns, 70 dimensions, 100 million or so rows, and that was it. And the company already, kind of exhausted all combinations and all algorithms and all research that you can do on a very limited set of data. And I naively asked, well, do you have some more data that we can try and look at and have some new perspective on what we can do? He said, sure. We're actually using a bulk storage. So what is now S3? So we started with Hadoop on premise, and we're just keeping it. And there I found a treasure. I found hundreds. So it was something like 600 columns and billions of rows. And it was like, it was wow. I found the most amazing treasure. And what we did, we started off with one statistician, and we started off investigating this type of data. And we saw that we can get more insights. And if we run the same algorithm that the company ran on a year or 5 years or 7 years on the same enterprise, we get mind-blowing insights. And we started sharing that at a very early stage with the customers. And they went, okay, we want this now. So off we went to do two things. One, to create a data science team to start research and start thinking differently and looking at the data and playing with way more data, way more granular, so we could aggregate it which way we wanted. and started to come up with really cool stuff very quickly, actually. And then we hit a wall. The wall was, how do you bring it into production? It was really, really hard, and the dime slowly dropped. That the game changes completely once you multiply or an order of magnitude more data. Means the data is a part of your problem. You cannot just go to production or do something like that. So I was faced with a dilemma. Either I build another data warehouse, another copy of the data, with a specific data model that will help me do each product, so like 6, 7, 8, 9, 10 copies of the data, each modeled in a different way, or be very flexible and play around with MapReduce queries written in Java inside my Hadoop world, which gave me a lot of flexibility. And this compromise I needed to do between this flexibility and speed and cost, and I discovered another thing, that you need actually people who actually understand in big data, building this pipeline, the data engineering, like you mentioned in your previous talk. All this, we didn't have the knowledge, we didn't have the right infrastructure. How do you build it? So there were so many questions, and throughout my career, at the end of the day, it translates into a SQL hitting a data server that is capable to give an answer in a reasonable time. And when you're stuck and your SQL can go for hours because you don't have 100 million rows, you have 100 billion rows,
right?
It changes completely the game. And one day I got a visit from two smart guys, 2/3 of the founders of Varada, and they told me a wonderful story. And they told me, you know what? All this data that you have in your lake, we can make it as fast as your data warehouse. You can query it, you can do whatever you want, and your customers can query it. And I said, okay, let's do a POC. They say, great, we don't have a product yet. It's only in slides. Wait a bit, and we'll have a product. And the next phone call, I decided to join the company and help them
Interesting.
break this barrier of analyzing huge quantities of data.
Interesting. I mean, what was the pitch? I mean, obviously it was being able to query data fast, but I mean, that's an interesting gamble in itself to say, oh, you got a slide deck. That sounds kind of cool. Let's team up and do this. So
yeah, the pitch was, you're suffering and I was suffering because I couldn't get. I had from one side my CEO saying, this is the goal, please make money out of it, because this is at the end of the day the goal that we all came to do, to make a profit, to make the company successful, and be ahead of the competition. And we did it, but we couldn't give it to our customers, which was very frustrating. And on the other hand, when we went to visit our customers and they saw, static analysis even of what we did with the data science team, they said, well, this is gold for us. I'm ready to pay. But I couldn't deliver, which was very, very frustrating as a product manager. You cannot deliver your product. And these guys came to me and said, you know what? We found a way of doing it. You can actually operationalize this data, the data that sits in your data lake, not model it and have like 10 copies. And then the cost was exorbitant. And then we needed the price of the feature was crazy high. So that was the pitch. And I said, okay, this is the future. This is where I need to be. And I want to be part of solving this problem.
That's really cool. I mean, walk me through that. What are the challenges of balancing cost and performance in analytics? This comes up a ton. I'm starting to see a lot more discussions in both areas. Cost, depending on, especially with a lot of newer cloud technologies, cost I think is becoming kind of top of mind. Back in the day, you would just buy a server and get a license and forget about it, right? Now costs are variable depending on your consumption model, and you want to balance that against performance, right? So. Yeah. I mean, how do you think about this trade-off?
This is exactly the tension point. And we see also the vendors of technology moving between the option of being very fast and very predictable, because you touched a really sensitive point, this pay as you go, pay by consumption, costs become something that you cannot predict. And CFOs in general do not like costs that are unpredictable. I was, while playing at ClickTel, was caught by my ears by my CFO and said, "You need to see your AWS bill, my friend. You're costing us a lot." Yeah, exactly. It was an oh boy moment. And it's exactly that, because you consume the compute and the cost becomes really out of control. So either you go and structure it very firmly and can predict your costs, kind of like the world of buying a server, but in the cloud. So spin up your Redshift, have a very strict data model, and you can predict your cost, your SLA, and you have your performance. But what happens when you want to go flexible? You want to do some ad hoc analytics. So you use tools. Let's go to the other side where you're very flexible, but then the price goes up. Tools like Athena or Trino. Athena is actually Trino serviced by AWS at the end of the day. And then you can be very flexible. But if you want to have SLAs that are user friendly, so under 5 seconds, for example, for a click, or something like 8 seconds, if you're very generous, you need compute, which will cost you for every query. We once and then, so the analytics goes in two ways for an organization. You have your internal needs, which can be massive. The internal analytics, the marketing analysts, your product analysts, your finance analysts, etc. And your outbound analytics, which is everything you sell out, the dashboard you sell, the metrics you sell, and the ability to query. And you want to be predictable on these costs. And the trade-off is either you have speed or you have flexibility. And this is where Varada kind of comes in. We kind of want both worlds. We want to have the performance so you can go to production, but at a really reasonable cost.
That sounds really awesome. So, you hit on something very interesting too. I mean, I'm starting to see a lot more use cases for external kind of client-facing analytics, right? Some people might call these embedded analytics. Some people might call these data products or applications. Regardless, I think the theme really is, it really comes down to fast queries. That's what people seem to be pushing. Are you seeing a lot of the kind of demand for similar type of stuff?
Huge demand, and in every vertical. Let's take the cybersecurity vertical, where you have data coming from endpoints that can be, in tens of thousands, and each endpoint can transmit every 5 to 10 seconds a kind of a batch of events, and the clients of the cybersecurity vendor, they want actually to do some analysis themselves. They have their own analysts, and they can join it with data that they have internally, and they can get to be very, very sophisticated. So now the big enterprises, they will demand from cybersecurity companies, well, I want to query my data, and I want to query not the last 7 days. I want to query the last 30 days. And I want this metric, and I want it fast, and I have 300 analysts coming on your system and hitting it with SQLs from 8 a.m. till 6 p.m., and I need it to be fast, because if not, they are not working. And we saw this frustration of, a team of analysts sitting like that and drinking coffee because system is down. Or
I don't know what you're saying, man, but I mean, that's. So walk me through this then. I mean, there's the notion of kind of hot, warm, and cold data. How does Varada think about that, or treat data? Does it have like a sort of a tiering system with data that needs to be cached, readily available, or is old data hot? Is old data warm? How does that work?
Okay, so let's touch a bit on what we do. We actually build an acceleration strategy automatically on top of the data lake. We are a solution that sits inside our customer's VPC. So we're not a SaaS, we're a cloud solution, but we sit inside the VPC. One of our philosophy is to keep the data where it is, and the data governance that was, so hardly worked and designed by the organization to keep it as is. So you spin up a cluster of Varada, which is wrapped, our technology is wrapped with the Trino, the open source project. We'll talk about it later on, but you spin up a Varada cluster that sits exactly between the data lake and the SQL consumers. The SQL consumers can be your internal ones, as we discussed earlier, your analysts, or your clients. You're paying clients for the external. So we're kind of a middle tier that sits inside the VPC that gets all the stream of SQLs and knows exactly what and how to accelerate and actually executes it automatically. Because there is a cost. As you said, we are a super fast, hot tier, but we know how to combine cold and super fast, hot data according to business importance, and all that automatically, because data engineering told us very early in the game, please make it easy. Don't give us more work. We have enough already. So we plan this acceleration strategy automatically with our algorithms that look and analyze the queries, understand exactly which column is being hit, which partitions are being hit, and what operator are being activated on this specific column. And then according to this information, we will decide what is the best acceleration strategy. Is it indexing, which is our core magic? Every startup needs one big magic, and this is ours, inline indexing of big data. We'll go into it if you like how we do it. Or actually cache the data. And we do that, and that's our second magic, inside SSD and NVMe servers, which we redesigned completely to our needs.
Are those like query cache results?
It's not exactly a query cache results.
Okay. Cool.
We also, it's a very elaborated index managed cache with no size limits, if you'd like.
That's cool. Interesting. Yeah, I was actually just writing about this the other day. Just data tiers and how you go about managing your data. So it's cool to see stuff like this automated. I always urge people to come up with some sort of automation on this anyway. But the cool thing I'm starting to see, the trend is definitely these query engines that were intelligent about how they prioritize, what data they're going to be using and that. I mean, how long did it? Was there something that Varada, before you joined, was something that they kind of had in that slide deck? Because I think this is actually a really interesting computer science problem to solve too. It's not easy, but I'm just wondering, like, how was it something that you guys kind of thought of? Was it that one before, or were you guys like working on this right when you joined? Just kind of get a sense of the complexity.
It's a very good question, because it is a journey. It is a journey. It is kind of a joint journey of us and our customers in this world of data, as you know so well. Everybody evolves. The first solution that we came up, the first version of Varada, was basically a materialized view.
Okay.
That held in this technology of SSD nanoblocks. I'll go into it and explain it in a bit. And we kind of sucked up all the materialized view in our cluster, and then it went super fast. So it solved some of the cases. We had clients that said, this is exactly what I need. But then others said, this is way too heavy and still expensive, guys. It is heavy because, what happens when your cluster dies and I want to take it down, and then I want to spin it back up, and then it's like 8 hours to load your cluster. That it doesn't make sense in today's world where everything is in consumption and they need it right now. So we needed to come up with something else, something that is automated, that leverages our core technology of big data indexing, managing automatically data in the cache, and leveraging this SSD NVMe technology that we're using. So the market actually drove us to this solution, and now we see that this is something that the market needs and the market is using. The market needs ease of use. The market needs real attention to cost, because you have solutions, but the cost of compute is just crazy, and the fact that it's unpredictable is crazy, and the organizations are starting to to feel it in their pockets and see that the spend on cloud becomes second to salaries, or sometimes even as equal or higher.
Yep.
Which, when you think of it, is really, really crazy. And you cannot find the right people, and you need the people that know the technology. So the market told us, be cost effective. Please, please, please be as easy as you can, even as an infrastructure element. Be easy to deploy, easy to use, easy to maintain, and elastic. You really need to be elastic, and so you can control, of course, the cost. I want to go from 0 nodes to 200, and it should be easy, and I shouldn't feel anything. And this is our evolution from more or less static materialized view into something very dynamic that can, in one query, manage super hot and fast data that resides inside Varada, and the data that resides in your catalogs in your S3, be that your Hive or your whatever catalog you're using, Delta Lake, Hoodie, or other.
That's really cool. I mean,
an iceberg.
An iceberg, yeah. Sorry, there's construction work going on upstairs. So
no
in case you hear like a squealing, it's. So let's talk about total cost of ownership here. I think this is something you touched on this in the cloud. Compute's expensive, storage is low cost. Any more thoughts on guys controlling costs? Because I think you're starting to see this kind of pushback in the cloud. I think to your point, people are like, it's great, except it's kind of expensive sometimes.
Yeah.
Any thoughts?
Yeah. So there is also attention there. Cloud is very easy. So spending money on the cloud is also very easy, because every analyst can spin up. If we take, for example, a SaaS vendor that is doing data warehouse in the cloud, like Snowflake, which is an amazing solution. They are trailblazers, these guys, and the biggest IPO of a SaaS company ever. They revolutionized the industry with that, and they gave an ease of use. And then the consumer said, "Wait, that's amazing. Let's now spin up a huge cluster and start having fun." But this fun costs money, and you need to somehow control. So it's a journey, and we evolve with it. So how do you govern this? Who can spin up a cluster? Who can write a freehand SQL that can, go for hours? And if you're using Athena and you're paying by data scan, and you're not very savvy in writing, the exact SQL and the order of filtering, so you will scan less data, you'll pay a lot. So organizations are saying, help us control the cost. And it's kind of contradictory, because they say at the same time, be easy. I want to click a button and it just works. But at the same time, you have to be very, very careful and cautious about our costs. And the first thing we understood that we need to do is elasticity.
Yep.
The ability, and this is something that is now very strong in the industry. When do I need? How precise can I be with my CPU consumption?
Mm-hmm.
If my day starts at 8 a.m. in the morning, and I'm an insurance company, and I have 300 analysts hitting the server. Now I need the system to be at peak, at hundreds of nodes running. I don't care, because I'm making money and people are working, and I need them to actually work. But at lunchtime, do I need 2 hours 2 hours of machines that cost per machine $5 per hour per machine, and you're looking
Right.
at 2 hours of idle time. So can you take it down, everything down, just half or 90% of your cluster down, and then back up for the end of the day, and then down again for nighttime, and then up again for your ETL nightly jobs that are going on. So this elasticity of infrastructure, this is now a kind of a way of controlling one aspect of the TCO.
Right.
Another aspect is, of course, the time of your DevOps team and data engineering team. This is also a part of your TCO and your capacity to manage and grow.
Right. One question I have, bit of a kind of a technical question about AWS, which you're on. I mean, how do you support multi-regional Varada right now?
So we install Varada in each region. We will support
Okay.
multi-regional.
Okay, cool, awesome.
If it's okay, or
Yep.
we have other questions, because I talked a bit about our magic, because we started off with indexing, and you might say, okay, indexing is interesting, and I imagine that in the audience there are people that face this indexing issue on other systems like Redshift or Postgres, so also very close. And it's expensive and it's slow. And so how do we do it not on 100 million rows, but on 100 billion rows, and we do it for any column, any dimension. So this is the base of our technology. The three founders of Varada, Roman, Tal, and David, and our CEO Eran, we started thinking of a new way from the physical side of looking at big data. If until this moment, if you remember the famous MapReduce white paper published by Google, the revolutionary one that made Hadoop and MapReduce come to life at the end of the day, they thought of big data of, okay, let's get this big chunk of 128 meg size of file, so the read will be once, and you'll enter the disk once, and then you'll read a lot, and then you'll go back with a big answer, and you'll save time. We thought of it on the other way around, using the SSD. We thought of very, very small units, break it down to hundreds of millions of very, very, very small units, which we re-engineered the SSD media. We write in Varada half in C and half in Java, so really close to. Yeah, we're really close to the actual media, and we redesigned the SSD media, and we redesigned it into nanoblock. Each nanoblock is of 1 kilobyte of size.
That's really small.
That's really small, and this is the kind of the physical bed, and you can imagine now SSD NVMEs by hundreds of millions of them split into very, very tiny nanoblocks of 1 kilobyte. So that's the physical bed that we prepared for the data. Then when we look at the logical data, the actual tables in the lake, this 1 kilobyte is the equivalent of 64,000 rows in one column. So this is our kind of glasses. This is the way we look at big data. No matter how big your table is, we'll always look at it in very, very, very small pieces. And what we do, so that's the bed that we lay to handle kind of big data. Now, how do we do indexing on that? So we do two things on the indexing. We do it inline, so we piggyback on the query. So we're very, very, very fast. So indexing is a non-issue, actually. It's actually S3 that will slow us down in building the index.
Yeah, I bet it would. Yeah.
Completely.
Yeah.
And the second thing is that we're adaptive. What does it mean? So since we cut it into these small pieces, imagine one column, let's say a column holding the age of your customers, which go from 1 month to 120 years. and you have a huge cardinality because you're using month, etc. But now you're looking only on a chunk of 64,000 rows. And in this 64,000 rows, you have only people that are age of 25, 26, and 27. And you have only 3 values. So now what Varada will look at is, okay, I have a cardinality of 3. This is an integer, a small integer. Here's the optimal index to index these value of this 64,000 rows. It can be a bit tree, it can be a bitmap, it can be a Bloom filter, or whatever kind of, or Lucene if it's text. So we'll pick and choose from an arsenal of indexes, and we'll take the 64,000 rows. We'll take the index, depending, again, we'll go and see how we take a decision on what to index, but this is how we index it. And then we'll push it to the nanoblock. And then at the end of the day, you have a network of independent nanoblocks that you can randomly access, so very fast, and actually you're running on an index and stabbing the right nanoblock and taking this data back to Trino that will give it back to the SQL consumer. And this is our core patent. We're doing this inline, and we're doing it very fast, and this accelerates up to 300 times more faster when you have selective query that needs filtering and can use indexing.
Right, there's construction going on.
Okay.
Actually, Tiago has a question here. What's up, Tiago? So Varada is competing with Databricks in a sense, question mark. Seems it does a lot of the same things in terms of jobs and orchestration, but it's harmonizing a broader variety of data sources, not just Parquet and deltas. And he says, plus the neat indexing. What do you think about this?
We are close. I mean, Databricks are an amazing company as well. They're doing similar things, and the major difference is our ability to do it automatically, which we didn't discuss. And as Tiago said, the neat indexing. This is our edge. Exactly.
That's really cool. Do you have a demo?
Yes. You know what? We can.
I'm always a fan of show, don't tell. You can tell, but let's check it out.
You are completely right.
And for the audience out there, if you do have questions, please drop them in the comments here. So, and apologies again, there's a bit of noise upstairs, so I'm more muted than I expected, but it's fine.
Okay, so this is live. How do I share my screen here? This is how I share my screen. Share screen.
You should be able to share a screen. Are you able to see the share screen thing at the bottom?
Yep.
Okay, perfect. I just need to add it to the stream here. Cool. Live demos. What could possibly go wrong?
Everything. But let's go. Let's get crazy.
Can you zoom in on that if you can?
Sure.
Cool. Thanks.
So let's see.
More.
Cool. It's a bit
maybe
too much.
No, a bit more actually.
A bit more?
Yeah.
Give me a second.
No worries.
Let's see if all this magic.
And maybe 2 more if you can do that. So, and if you can't, no big deal. So make sure people can read that.
Is that okay? Or
I think so. Yeah, if the audience can see that. Yeah, 1 more would be good. Yeah. Perfect. Good. Thank you.
Okay. I never worked in this resolution. I don't know.
Okay. Yeah. So it's probably weirder for you than it is for us. So.
So we have a typical query for companies like the Uber of the world, or ride sharing, all those ride sharing scoots, etc., where you want to have a cohort of your top drivers, top riders, or whatever. And in this case, this query has let's look at the columns that, let's try and think like Varada in this case, and see how Varada will analyze it and what it will do. We have the driver ID column that is being hit in the select from this trips data table, and you have the date with the selection, again a group by for driver ID, and having a condition on the group by. Then I have the T hour column, and basically that's it. I have these columns. And in this use case that you're going to see, driver ID is the first time that is being introduced in the workload. Okay, that's a new query that is coming in. All the other columns have been treated, and Varada will now take several decisions based on this specific use case, because it sees driver ID, for example, in two places, in the group by and in the where clause. So when Varada sees that in the group by, an index will not help me accelerate, right? Because I need data to group by. So here Varada will take the decision to take the data and put it in those famous nanoblocks. But on the other use case, here where driver ID appears in the where clause, Varada will decide to index it, because where is a filter, and filter can greatly use an index. So let's hit run and see a cold run of this query. Okay, it is running. And I want you to, I don't know if you can see, but this is the, can you see here? Or
yeah, I can sort of see that. Yeah, the elapsed time, and I'm looking at the process rows, and it's now in the billions.
Exactly. So
yeah.
let's follow these numbers. So what happens now, and this is the magic of Varada, while this is running, Varada already took the decision. So it is looking to see which columns are already indexed in Varada and which columns have data, and will know the driver ID is not, and will do it automatically.
Right.
Unless, and this is something important, unless our users will tell me, you know what, I don't care about this user, or I don't care about this column. Never touch this, because I want to save money, or I want to save storage, or I want to save CPU, or I want to save something. They can guide also Varada API-wise or UI-wise on importance of users, on importance of workloads, and then you can even control your costs in an even more efficient and precise way. So if we're looking at this first run of the query, we see that it ran for 41 seconds, and it processed 10 billion rows, 46 million, blah, 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 and some banana. And now if I hit run again, let's see what happens. Okay, this is what happens. Let me, this is too big. Now it's good. Can you see that?
Yeah.
Okay, so from 41 seconds, I passed to 1.1 second. And what I did is indexed and data, what Varada did automatically, I indexed and data and grabbed the data of driver ID according to the strategy of this specific query. And from 10 billion rows, I went down to 2 million rows. And this
That's pretty smart.
This is the magic. And this is where we save in CPU, which means saving money, which means you can do a lot more with your existing CPU if you're using this kind of technology. I really enjoy this technology, because this was exactly my problem. Because now you have a workload. I don't need anybody actually to look at it. I don't need anybody to model it. I can just throw it on Varada, let Varada understand it. I can give it some rules and regulations on what's important to me and what do I want to spend money on. And let's say that I have an external client and this is the highest priority. And every time this user asks you a query, please use as much space as much CPU as you want, and reduce the time. And you can imagine that coming from 41 or 42 seconds to 1 second is considerable.
Oh yeah.
In this case, all this good stuff that we wrap. So the understanding kind of the brain of Varada that reads the SQL and analyzes it and takes the decision, and then actually doing it and putting, as you saw, this in our SSD. This is all wrapped with Trino.
Nice.
An amazing open source project, the distributed SQL engine. For the community, it was called once it was called Presto.
It used to be called Presto. Yeah. Now it's called Trino. Shout out to the Trino community, by the way. Brian Olson, who regularly tunes in, who was actually on the show a few weeks ago. Yeah, and we're also ternary data partners with Starburst. So yeah, nothing but love for the Trino and Starburst peeps. So
completely from our side as well, both for the Trino community, we're contributors to the open source community. We have the dynamic filtering, if you look in the Trino project, is written by Varada and contributed to the community. We're very close friends with Starburst, with Brian, and Martin, and Justin, and Dane, and David, and all the guys. They're an amazing team over there. And we also look at combinations of Starburst and Varada doing some crazy stuff together. What we also, so we decided to bet on what was once Presto as an open source to wrap and kind of solve a lot of our problems from a lot of perspectives. Taking this open source project that was initially written as an open source project actually by this team in Facebook. Then there was this fork, and you have your Presto DB and Trino. We are in the Trino community, and we're wrapped with Trino. We really believe in the community play, in the force of the community and the collective wisdom of the community. And we also believe that, as you said, don't talk too much, don't explain. Just show me the technology and show me your solution, and let's see what it does. And kind of this is kind of what we're thinking. We're dealing with very smart data engineers and developers and data architects, and they just want to play around with it and see if you're talking nonsense or this stuff actually works. So what we decided to do was to create Varada as a Trino connector. So everything that I explained, we have two ways of deploying Varada. One is a Varada cluster, so you have your Varada Trino cluster that you spin up. We have a way of spinning it up very easily, but the second mode of deployment is as a Trino connector. So it's a tar GZ file that you put on your connector. You put on your coordinator and your workers on your Trino cluster, having your machines with the SSD, and now you have really a lot to choose from AWS's SSD machines families. And we decided to give it to the community, to do a community edition of Varada as a Trino connector. Because if you're already using Trino, just put us as in the community edition. It's limited up to 4 nodes of Trino, and use it. Use it on your own data. Use it in your own VPC, and use it for life. It's
That's
free,
cool.
limited only in size. Also, I will use your great platform here to call also universities. We start to see universities downloading our community edition and joining our Slack, going through our Varada.io website.
Interesting.
to do research, because we have a customer that is doing pharmaceutical genomic research using Trino and Varada, because it's super fast, and then data science team can do that. So it will be amazing for us to see also the academic world using our community edition and pushing us to the limits. For those who don't have a Trino cluster up and running, just spin up Varada and try it out and compare it to your Athena usage or your BigQuery, and see what fits. I think, as we discussed earlier on, everybody's on this big data journey, and it's a journey. It's not static. It's not the old world anymore that you take, your IBM or your Oracle, and that's it for the next 15 years, and you build your expertise. It is moving so fast. It is moving so fast, and there are so many technologies, and every technology will hit the good spot of a specific use case. So I think the way to do it is not to push it, but let people use your solution in their real context, and use it for as long as they want, until they say, okay, this actually solves my problem. Now I want to engage with the vendor and see if it fits, and if there is an economical sense of doing it. But the first thing is just use it, and
that's
especially coming from the open source kind of philosophy and mindset. We're really proud of this, and we really start seeing a lot of good usage of our connector in the community edition. So I invite you all to join our Slack in the Varada connector, and go to our website and just use it. See if it does something for you. You can just spin up also a vanilla Trino and hook up our connector inside.
That's really cool. Actually, kind of on a related question here. This might somewhat related. Tiago also asked if I have millions of users with an ID, string UID, I could index multiple tables from different databases that use the same user ID system and speed up join queries significantly when compared to pure Spark.
That's a good question. So we have the ability to join with Trino. What we accelerate is what resides on the data lake. Okay, so let's say you have X tables on your data lake, that will be accelerated in the same manner that you see here. String UUID or is common, so we see that will be, I imagine, in Tiago's use case, the link between all the joins that I imagine elaborate by the question. But then we'll use Trino to join the other data sources with Varada and with the data lake. So we accelerate whatever resides in the lakes, but we can join everything. We have customers that saw that joins actually will work way faster when the tables reside in Varada, or the specific columns reside in Varada, because you can do kind of a zip join using filtering. Depends. Again, I would love to discuss with with Iago or anybody else on that matter, on how you can use dynamic filtering, how what type of joins you have. Can you project the small table on the large table? Then we can do some more magic. So that's the short answer is yes, we can join. We accelerate what is on the lake, but then we need to see the specific use case. Maybe it's worthwhile to bring the major tables, or the small table or the big table in Varada.
Yeah, that's a good question. Awesome. So what's next for Varada? Any I know you just came out with the Trino Connector recently, so maybe that's still trying to plug that out. But I guess what's anything cool in store for 2022 people should know about?
Oh, a lot of things.
Okay.
We will release our Varada Control Center very, very soon, which will be a way of visualizing and understanding your queries, spinning up Varada, even installing your connector. we will add aggregations more and more. Our strategy is in two ways. First, to help more and more use cases inside the queries, so more aggregations, more types of queries that we can help with. So this is one product direction that we have. And the other one is the ease of use. We want to be able to accelerate more and more types of queries, more types of indexes, getting smarter with our understanding of the queries. That's kind of the general direction that we're going.
That's awesome. Cool. We're coming up on time, but it's been a really fun chat, and I do appreciate talking with you. Yeah, it seems like a really cool product. I know I'm going to be checking this out and trying to incorporate it into my Trino workflows. So
cool.
I urge everyone to do the same. For people who want to know more about Varada, how do they do that?
Go to varada.io, or just sorry, I'll use an archaic type of communication. Email me,
okay,
or on Ori at varada.io, or join our Slack, and then we're in a normal way of communication.
Is that a Slack community available through Varada's website?
Yep. You can join our Slack community through the Varada website, varada.io. Join our Slack, and we'll be more than happy to answer your questions and talk with you.
That's awesome. Cool. Well, it's been a fun chat, and hope to have you on again. So yeah, thanks. And thanks to the audience for the questions. And we'll see you next time. We will not be doing a Joe and Friends show next week because it's getting close to the holidays. But we'll be actually, let me just make sure I'm not totally full of it. Nope, I don't have anything scheduled. Sometimes I do that to myself. So, yeah, and got some exciting shows coming up. Actually, for the Data Nerd Herd, we're going to be dropping a fun interview I did with Brian Sook. He's the associate CTO over at SADA. Then got another one coming up with Eric Shetter. He's the person who wrote Apache Druid. So
I'll join in for this one.
Yeah, this is gonna be a fun one. So Monday morning data chat. It's gonna be Matt and I think for next week. And on the let me see here, the 27th, we got Luigi Petruno. So if you're in ML Ops, you'll know who he is. He's made a lot of cool content on that. So we got Luigi on the 27th, and after that, on coming back to the new year, we have Ben Rogojan, the Seattle data guy. And I believe after that, we're trying to get him on the show again. We need to coordinate the times, but Andreas Kretz, who is putting out a lot of awesome data engineering content. So stay tuned. Busy content schedule coming up, but hope you all enjoy it, and hope you all enjoy the holidays too. So, Ori, thanks again.
Joe, thank you very much for having me.
Anytime.
It was a pleasure. Thank you.
Yeah, of course. See ya.